Today we are doing lesson 10.4 using inscribed angles and polygons, and the goal is to solve for inscribed angles and their arc. An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of a circle, right? So this side is a chord, this side is a chord. The arc that lies on the inside of the inscribed angle and has endpoints on the angle is called the intercepted arc. So this part, the red, is the intercepted arc, and the blue angle right here is the inscribed angle. Now the relationship for these is the angle equals half the arc. So when we are on the circle, angle equals half arc. There are three cases for this, and the one we will prove is the one on the left, where the center is on the side of the inscribed angle, and we'll use that to show how that works. So, moving on here, proving case 1. Angle B is inscribed in the circle. Angle B, we're going to just say it equals x degrees, and Q lies on BC. We need to find measure of angle B equal to half measure of arc AC. So create a plan for this proof algebraically, and go ahead and pause and try to figure out how we can do that. So, key thing to know is that all of these segments are congruent. QA, QB, QC are going to be congruent. And from there, we're going to do something with this isosceles triangle. And then we also have a theorem that tells us what this angle equals in terms of these two angles. And then we can find out what arc AC equals in terms of x. Solve for x, which happens to be angle B. And that will be how we do it. So on this next slide, I've already inserted the proof, and we'll kind of reveal it step at a time. So given angle B is inscribed, right? Angle B equals x. Q lies on BC, just to say this is case 1. Reason given. Step 2, QA equals QB technically is also equal to QC, but we don't need all three. You could also say congruent, but in general, we're just going to say all radii are equal or congruent. Again, you have that flexibility there. Next, if these are congruent, then we have an isosceles triangle. We don't need to say that. We just say, hey, if these are congruent, then the angles are both congruent. So now we've got angle A and angle B are both equal to x by base angles theorem, right? QA equals QB shows you it's isosceles. We don't need that definition. But if the sides are congruent, then the angles are congruent, right? Backing at using these triangles. So, right, with congruent marks here, we've got these are congruent. And now, then we're going to, that says this is x as well. So we got two x's in here. Next, AQC equals A plus B angles, which is 2x, right? So as a reminder, this is the exterior angles theorem, right? If this straight line tells us that these two add up to 180, and we already knew these three angles in the triangle add to 180. With those two, we can say this angle equals A plus B, and that is exterior angles theorem. Just a reminder, it's of a triangle. You wouldn't need to write that, but just as a reminder, that's where that exterior angle comes from. Next, we have, right, if this equals 2x, right, we just figured this out. This is 2x. Therefore, it's a central angle, and this arc equals 2x. Right now, how do we compare these? Arc is 2x, B is x. So arc is 2b, and we need to solve it, right? The measure of the arc is 2b, but we want angle B equals half the arc. So that's kind of what we have here. We just need to substitute in, kind of, right? We already know x is b. So we're going to say solve times half on both sides, and we got half of arc AC, I forgot my arc mark here, sorry, equals x, which is angle B. So technically, that's what this says. I probably should have put the M in there here. Let me squeeze the M in there. Or just say measure of angle B if they'll let me do that. Might not let me do that. Anyway, and then that was by division, right? From here to here times half on both sides, or divide by 2. And then there's our theorem. Moving on. Now we're finding some examples here. Given angle QRT is 50, find QT, arc. And then given arc RS is 48, find angle RTS. So with this one, the shortcut I kind of mentioned a little bit last time we were meeting was that angle equals half arc is for when you're on the circle, right? So angle equals half arc symbol, and we've got the arc, so we just want the angle, RTS here, angle half of 48, and just plugging it in gives you 24 degrees. If we're solving for QT over here, right, this segment over here, we've got the angle equals half arc, so what we have is 50 equals half of what, right? So we're going to multiply by 2 on both sides, and we get 2 times 50 is 100 degrees, is our measure of arc QT. Lastly, what about QR? And this is a reminder, we have this line here, which shows us that TQ plus QR is 180 because TR is the diameter. It goes through this point, which is the center of the circle. And so because of that, we can do 180 minus the 100 we just solved here, right? We have this as 100 from this last problem. 180 minus 100 is 80, is arc QR. Moving on, we've got find what RS equals and the measure of angle STR if we have 31 degrees here, right? Angle equals half arc, so 31 equals half of what number? So we times 2, we get 62 degrees over here for the arc, and then this happens to belong to this inscribed angle as well, and so angle equals half arc, and this one equals 31, and look, they both have the same intercepted arc. I don't know if I can flip it out here. These both have the same, these two angles have the same arc, and so they are going to be congruent. And so we don't have to do that math every time just to like figure that out. We'll just say if two angles, right down here, if two inscribed angles of a circle have the same intercepted arc, then the angles are congruent. Now, in this picture, you'll notice it's saying, oh, angles C and D are congruent, or ADB and ACB are congruent. We also have these angles over here, both have arc DC. So angle A and B are also congruent. Just a little note on that. So it's pretty easy to get similar triangles in these problems. Next, a couple more problems. Find the measure of the red arc or angle. So in this case, we're finding angle G. Angle equals half arc. Arc is 90, so what is half of 90? So to find these angles again, sorry my boxes weren't working, got it fixed now. Half of 90 equals, right, angle equals half arc, so angle is 90 equals half arc. Yeah, angle equals half arc. Arc was 90, pardon me. Half of the arc 90 is 45, and so HGF angle is 45 degrees. Same thing down here, angle equals half arc, so 38 is half of TB, times 2 to both sides, and we get 37, 2 times 38, 76 is arc TV. Next, how does this work with polygons? And inscribed polygons is when all the vertices, or vertex, plural, right, lie on the circle. The circle containing the vertices is called circumscribed, right? We kind of talk about the circumcenter and things before, right? So in this case, we've got two properties. We've got if a triangle is inside a circle, inscribed, and we have a line that goes through the center, right, say the diameter, right, in this case AC is the diameter, therefore angle ABC is 90 degrees, right, because this is 180 arc over here, A to C is a semicircle, and so half of 180 is 90. So measure of angle ABC is 90 if and only if AC is the diameter of the circle. Just to kind of show you mathematically where that came from in relation to what we just learned. Theorem 10.10. How is this going to work? Now, this one technically we could prove. We won't, but let's look at arc angle F for a second. Angle F has arc BDG, right? And then angle D, right? So these two, angle D arc is from here to here. Well, what did we just do? We have the whole circle there, right? So angle D plus angle F equals these two arcs, which equal the whole circle of 360. But remember, angles equal half the arc. So if we have the whole circle is 360, our angles are going to add equal 180. And so that's what we have here. D and F add equal 180, and E and G add equal 180. You don't have to say they're equal to each other. We're mainly going to relate that they're both supplementary. So first couple problems here. We've got one value we're looking for, right? 80 plus x, because they're opposite of each other, will add equal 180. 75 plus y add equal 180, and it's just a quick subtract 80 from both sides. X is 100, subtract 75 from both sides. Y is 105. Down here, same idea. They might not look like opposite side, but 2a and 2a, angle L and J are opposite, so 2a plus 2a is 180. 4a is 180. Divide by 4, and we get half of 180 is 90, half of 90 is 45 degrees. This side we got 4b plus 2b is 180, 6b total, right? 4 plus 2 is 6, and b is 30. I believe this is about the last slide we're at here. Find the value of each variable. We've got c and 2c minus 6, so we got one more example after this. And so those add together to equal, over here, equal 180. We got 3c minus 6, but we're going to plus 6 to both sides. 186 is 3c, divide by 3, c is 62. 10 plus 8 is 18. 18 times something is 180, and x is 10. Down here, y plus 68 is 180, x plus 82 is 180. Solving quick, pretty straightforward, right? So again, I usually speed past the end of these, but if you feel like you need to pause to write things down, feel free to pause the video to finish writing down what you need on this slide. Next, I made one of my own up because you may have fraction in the homework. How would you deal with this, right? We've got a right angle. This is 90 by this line. So these two have to add equal the other 90 degrees. So half x plus 1/3 x plus 5 equals 90. I'm not a big fan of using fraction. Maybe you are. So what I typically will do is be like, well, what's my least common denominator, right? So half doesn't go into third doesn't go into 2, but they both go into 6. LCD is 6, so then I multiply everything by 6. 6 halves will be 3. 6/3 will be 2. 6 times 5, 30. 6 times 9. Every single piece gets the 6. So I showed that this time by just basically putting 6 in the numerator. 6 times 1 technically would have happened. But now simplify. 3x plus 2x plus 30 is 540. 5x equals, right? These are 5. Subtract 30 from each side to get 510. And then I added these together, kind of 2 steps in one. X is 102. Now first you're like, whoa, whoa, whoa. Look, this is a triangle. 102 plus 90 is not going to be 180. Half x is your angle. So your answer can be above 100 because half of 102 is 51. So this angle still is less than 90. But just a heads up on that. So because I got a weird answer, I'm like, well, plug it in, make sure it makes sense. Half of 102 is 51. And then plugging it into the 1/3 to the other side, 1/3 of 102 plus 5 gives us 34 plus 5 is 39. And these two angles add to equal 90 is my double check, hence the check mark. And that wraps up today's lesson. Feel free to check out the homework on Moodle and Google Classroom.